Now, some of you have heard me speak before, so I've tried to kind of progress past that. But for those that haven't, I've got to do some catching up. So I want to introduce some concepts that I've talked about before. And an important one is called environmental security. That's what I do my research on. I'm not just a climate change guy, but I look at those things that are environmentally driven, that are of such a magnitude in change, that they become security threats to people, regions, and even internationally threats, like climate change. Climate change is the big hot button right now, but there are others. For me, the scariest one is water security. If you look at water around the world, you know, as the sage says in the West, you know, whiskey's for drinking and water's for fighting over. Well, that's an environmental security issue. They attribute that to Will Rogers. He did not say that. We can't find it. Nor did Mark Twain. But I want you to understand that. And then the relationship between those environmentals and peace and stability. And then I like to use case studies. So for environmental security, we're going to look at the case study of the Nile River, which I think is uniquely interesting because of the security implications. The security implications being, if Egypt goes down, we have no foothold in trying to progress in a peaceful resolution of what's going on in the Middle East. We depend on Egypt, and Egypt depends on the Nile. And you need to understand the threats. So that's a national security and an international security issue for us. That shows how something that's going on all the way around the world really does matter to us from a national security standpoint. And I want you to understand that. Then we're going to go into climate change. I'm going to do it in two ways. I read all 2,200 pages of the science document from the 5th assessment report put out by the UN Commission on Climate Change, trying to understand what were the security and defense implications in there, but also understand the science. So I'm going to go over some of that, particularly highlighting how that changed from the reports. They've been doing reports since 1998. How it has changed and progressed, and how much more we know than we knew those 20 years ago. And to reflect that, I'm going to use another important case study, which is a study of water security driven by changes in the climate in the Tibetan Plateau. And I'll explain to you why that's really important. And then we're going to finish up, and we're going to look at what went on in Paris in what they call COP21. That's the meeting of the participants from the 1994 Kyoto. The 195 nations that went to Kyoto in 1994, they have been meeting regularly since then. This is the 21st meeting of that group. And we're going to talk about the progress that was made there. It's been the most significant of all. So it's worth looking at. So that's what we're going to talk about. Any questions or any other things that of interest right now? Go ahead, please.
The timeline, how some of the stuff that happened in the 70s is catching up with us, or whatever we do now won't be built for 20 or 30 years. I don't quite understand how the timeline works.
I'll get to that. That one we'll talk about in the science, but I'll make sure we get into it at the right point when I've got some data up that you can look at and you can understand that. Do they have a microphone?
No.
All right, I'm going to bring it up for you. Thank you. I don't have my hearing aids yet. That's how you can tell I'm a retired military guy. We all have hearing aids and we all limp on one leg. Our knees are gone. So we're going to start with environmental security. The first thing you have to recognize is, I didn't think this up and it's not new. Read this statement. This was a very important social scientist out of Harvard University, and in 1986, after years of study, this is the way he described the environmental security issues. National security is not just fighting forces and weapons. Watersheds, croplands, genetic resources, climate. In 1986, it was pretty obvious to the people who looked at that things were changing, and those changes were not for the better. And it's something that you had to think about from a security standpoint. And there were a lot of scientists that were involved in that work, but it never really got traction. Another quote that I'll just go paraphrase from memory is that This was stated by a guy named Liddell Hart. He's a famous military strategist from the 1900s. He was a British strategist. And his statement about this that's so applicable is, the only thing harder than getting a new idea into a military mind is getting an old one out. And that's kind of where we were with this. They know forces and weaponry. Climate change, and oh man, that's hard to understand, and it doesn't seem to fit, so I don't want to do it. And we did that for a long time, but as you'll see, we in the military have changed also. We understand now, and we've made great progress in trying to identify and start to develop a strategy to work on climate change and security issues. Now this is my context for environmental security. Just not being at war doesn't count. That's not sufficient for what we hope to achieve from a military standpoint. We want peace, and to provide peace, you have to provide a safe and secure environment, provides for people's basic human needs. If people don't have what the land, the water, and the air is supposed to give them in a sustainable way, it destabilizes them. It creates environmental refugees. It creates mass migrations. It creates epidemics. Those are the threats from a security standpoint we have to recognize when we talk about climate change issues. And that's one of the things that you'll recognize. Or water scarcity, or desertification. Those are all environmental security issues. That make sense? Yes. Anybody? Okay, we go further on that. So we went there. I said we've made some progress. I spent 20 years trying to convince the military it's not the only threat, but it is a threat, and we need to do the same kind of analysis we do for that as we do the threats for weapons of mass destruction, the threats for terrorism right now, the threats caused by drugs. Those are all important strategic defense issues. But there's a whole list of those. We don't run out of targets, but this has to be one of them. The National Security Strategy of the United States is the highest level direction to the whole of government of what is important about our national security. It's written by the President, comes out of the White House, the National Security Council writes it. It now states the danger for climate change is real, urgent, and severe. Even the military mind can get that one. We understand. You got it in a nice, simple sentence. You put it up front. So we got that. The one I want to emphasize is embedded in the document, promote dignity by meeting basic human needs. To me, that is the big finding there. If you don't do that, that's where it all falls apart. That became obvious to me. I have been to 52 different countries, wearing the uniform, doing all kinds of different things. Humanitarian operations like Rwanda in '94, when we had 1 million people that had been displaced by the genocide, and they were all on a hard piece of rock in Goma, Zaire. And our job, as it was given to us by the President, was to stop the dying. There were 5,000 people a day dying in the refugee camp at Goma, Zaire when we moved out to stop that. We spent about 120 days there. The refugees were there for more than 2 years after we left. But we had greatly reduced the effect of disease on that population by the time we left. That's what promoting human dignity provides. If those people can go home, back to their agrarian society, back to their little villages, they can sustain themselves, as long as those resources are not denied to them. We won't worry about this, but this was significant. This is the reason that cartoon was made. The bottom one is a document the Department of Defense produced for itself in 2014, which it called the Climate Change Roadmap. What we as a Department of Defense are going to do in response to climate change, both internally for what we need to do as a very large business that happens to be all over the world with post camps and stations, many of which are endangered from some of the climate change issues. And also what we have to do to develop a defense policy appropriate for the United States to adapt and mitigate. Those are the big words that the UN has developed. Climate change is real. It is coming. We've already bought 100 years worth of climate change, because the stuff that has already been put in the air has a residence time of about 100 years. Now, it takes a lag time for it to really start to take effect, but it takes for 100 years for the carbon dioxide, the methanes, the oxides of nitrogen to clear out of the air. You remember the hole in the ozone layer and how we reacted positively to that. We got rid of the chlorofluorocarbons. In another 85 years, they'll be gone, because they have the same residence time in the upper atmosphere as carbon dioxide has in the rest of the atmosphere. So it's recovering, but it's going to be 100 years before it recovers back. That's that lag time thing you have to deal with in the environmental response. It goes up slow. Even after we quit putting excess carbon into the atmosphere, it'll still continue to warm. We'll talk about that when we look at the stuff that came out of Paris, because they recognize that and they've tried to make a set of responses that as quickly as possible level off the rise in temperature, the other impacts of climate change. We all think about climate change and it's getting warmer. There are 7 major impacts of climate change. Not just getting warmer. Extreme weather is one of those. We're going to explain how that works. Okay, we're going to get into the science a little bit. El Nino, La Nina is a natural system. It has occurred for thousands of years. But the ocean is getting warmer. 90% of the heat that is created through global warming goes into the ocean, not into the atmosphere. It's warming significantly. That means El Nino is much more powerful because there's more heat. And that's what it's doing. It's trying to dissipate heat. The massive amount of heat that every once in a while collects up in the Western Pacific. So I'll go over that.
That includes all these catastrophes.
Yes, there's more energy in the whole global system. And what is climate? The climate is trying to mix up so that hot mixes with cold, and we get to an equilibrium. It's basic thermodynamics that you study kind of in your freshman or sophomore year as an engineer. The bigger the difference, the more violent the mixing. The more violent, both in the number, but also the magnitude of the storms that come through. That's one of the significant impacts, and I'll go over them. Yeah, that's a misnomer. Everybody thinks, well, it's just getting warmer. I can probably live with that. Well, you can't live with 12 degrees centigrade warming, which is one of the predictions. But there are lots of other things, and you just highlighted a couple of them. So we'll talk about that. This is an important slide. This is BCK, before Chris King. 2.5 billion people. That's a lot of people. Here's today. 7.2 billion people. Now, you all have already accepted my premise that it's about building communities that can be sustained, that over a continuing basis can meet their basic human needs. So where do you think most of those 7.2 billion people are? They're at the basic human needs. They're in a day-to-day struggle for clean water. And if you don't have clean water, you drink dirty water. What happens there? The World Health Organization expects that 3 million people a year die from dirty water. And more than 2 billion get sick from dirty water. And that's debilitating for a developing nation, to have that much disease and sickness. 7.2 billion. This is really what got me started in this. As I deployed around the world, lots of humanitarian ops and stuff. What is going on? You know, you get out there and you try to struggle and explain to yourself why this is occurring. And then you do your research and you try to dig through the science. At least I'll dig through the science, because that's what I'm interested And it sort of all started coming together when I started reading people like Norman Myers and Thomas Holman Dixon that explained, yeah, stupid, there is a connection between the basic physical environment and the human environment. You've got that beautiful, beautiful world that's been created for us, and now we keep putting people on it, and more people and more people.
So does that many people make any difference in the carbon dioxide?
Yes, yes. Each one has a basic carbon footprint. I know they talk about that here. And that many more people is just going to continue to need some basic energy, some food, water, and it grows and grows. And oh, by the way, you think, well, you know, we're modernizing, we've got technology is going to win. If you look at the data, the developed world uses per capita much more than the undeveloped world. So it doesn't get better because of technology, it actually gets quite a bit worse. The basic requirement for water that's been defined by some of the best researchers, 50 liters per day per person to survive. When I design a house for the United States, I design the house for 250 gallons per day, not liters, 1,000 liters per day, or about 200 to 250 liters for every person. That's what technology has done. It increases the appetite. So this is something that we have to recognize as part of the players, like you said. So how does that impact the whole equation? Badly is probably the right answer. Here is a big problem for us. We live in a developed, highly technological. You consider the water problems we have in the United States, the problems that farmers are going to have because they're losing their ability to farm in the ways they have before. Ask the folks in West Kansas about their ability to continue to farm as they were. We have the technology to drive change, to mitigate, and to adapt. The rest of the world cannot do those kind of things. I always make the joke, we don't have water problems in the United States, we just have a whole bunch of people in the wrong places. But we can move that water around, we can move the people around. Those 7.2 billion people that are challenged, there aren't any places for them to go. They already live in the margins. I'll give you a great example. Think about the Katrina, you know, the violent storm there. We knew where the water was going to be. When I taught at West Point, I had a picture of a Corps of Engineers guy standing with a gauge in the middle of Bourbon Street pointing 16 feet up in the air exactly where the water was going to come when a stage 4 hurricane hit that coast. We knew the water was going to be there. So why did all the people get damaged? Because they all lived in the margin. They moved into places that they could afford, but it was way in the floodplain. It was a 20-year floodplain. It was the 50-year floodplain, not the 1,000-year floodplain. So they all got wiped out, and then after the thing was over, the politicians said, we didn't know, and we're not going to let them move back. Well, they did know, but we didn't want to spend the money, because it was very expensive to try to protect that. But now where do those people live? Well, that's a microcosm of the people in Bangladesh, the people in many places in the world. I'll use Bangladesh as an example several times. A friend of mine was former chief of staff of the Bangladeshi army. He leads a group that's focused on climate change. Bangladesh is ground zero for everything bad that can happen. And I've got a map and you'll see it, why I say that. Minimum, climate change is going to displace 35 million Bangladeshis. 35 million, minimum. We're talking about tens of thousands of refugees moving from Syria because of the fighting. 35 million? There's orders of magnitude kind of different in that.
Yeah, with respect to your population, if you take the current rate of increase of people, which is the Simulog plot,
yeah, that's it.
Well, if you extrapolate that to the year 2100, you'll get 26 billion people. So someplace in between now and then, something drastic is going to happen. Can you comment on that?
Well, nobody extrapolates it out to that.
No, I'm saying that the current rate.
The demographers are now predicting it's going to asymptotically settled to somewhere between 10 and 12 billion
What
people.
determines that?
A wild guess, not a wild guess, but the best information that they have based on it starting to tilt a little bit.
Okay.
But
Because the thing is, if it's.
We don't know the carrying capacity of the
Right,
world.
right.
We do not know.
'Cause the
You know, a farmer
economist-
knows exactly how many cows he can run on a 50-acre farm, depending on where it is. Or what you have to do if you're growing some crops and you need to let it lay rest for a couple of years. We don't know that about the earth, and oh, by the way, we couldn't control it if we had to. Because we don't have that mechanism there to control it. Sir?
Well, maybe he's asking the question of, do we know how much food we can produce given the other trends? No.
No, we have continued to be able to produce more food. The problem is we're mortgaging. We're doing a balloon payment. We're overusing. I mean, that's what causes desertification. They put more cows on a very arid piece of land than are goats or sheep. And it lasts for a little while, but then it collapses. We don't know that point. There is not a sufficient amount of data to make a good estimate
But we're
of the
assuming,
carrying capacity of the land. The concept is well known. Now, to tell you what science says it goes up here to a certain point, we overpopulate significantly, and then you get a die-off,
Yeah, you
an
have to-
extreme die-off. I see the science guys around. That's the classic model.
Yeah, but I mean.
Can we beat that? I don't know.
Well, I guess my question is, I'm not entirely sure what goes into that model, because if you take the current rate and assume nothing changes, it will predict 26 billion people. So someplace it's got to drop down, and that's what models are. But I'm not sure what goes into those models.
Yeah. What we see right now is the growth
Yeah, right,
has reached a fairly steady state, but it hasn't turned yet.
right.
The only thing that's turned that model recently is in about 2000 we tilted it back down a little bit. HIV in Africa. It reduced the population growth rates in Africa for a short period of time so that we reduced the overall estimates. Is that the future? I don't know. Please, ma'am.
Relating to the population growth, I remember, I'm just 5 years younger than you, so I remember in the 70s.
You're doing better than I am, by the way.
Early 70s, when the population bomb put by an airlift
Yes.
went on, I made a decision at about age 14 that if I ever had children, I would not have more than 2. So I've had 2. Each of my children have made that same decision for the same kind of reasons. And it hasn't, I don't know how many people read that book and took it seriously.
I can tell you where they
and made
didn't.
that kind of decision. And that chart went up significantly during that time period.
Let me give you an example. Last time I was here, I used a case study of Afghanistan, the third poorest place in the world that's been wrought with war forever. You know what the fertility rate for an Afghan woman is? 7.
As the poorer people are, the more children they produce.
There's
Statistically.
there's population geography that talks about it, and there's a 4-stage model. Early, that's the model, and then it levels off, and you reach, like Europe can't even maintain its population right now because they got a negative population growth rate. Many of East Europe have a negative population growth rate. But many places in the world, you still, my research has defined my environmental security parameter as population growth rate plus water plus land change plus loss of trees, and it just models failed states perfectly. If you have all of those things that are going negatively for you, population growth rates at high rates, you overuse whatever you've got, whether it's plentiful or not, and you get to a failed state. Good, sir.
In Uganda, the top quartile by income and education has 3.2 children per mother. The bottom quartile has 8.4.
That's the data set, sir. It really is. So I just put this up to show you that it's not just climate change. It's all of these things. Anything the water, the air, or the land does in building that sustainable condition wherever you live in the most arid parts of the world or the most plentiful part of the world, when you start messing up this balance, that's when you have an environmental security issue. So, I told you a Nile case study. The Nile River. This is the Nile at Cairo. If you take a picture at Alexandria, which is the next place down the road, it's pretty much dry when it goes into the Mediterranean. This is the political map. Here is Egypt. Here is all of the Middle East and the many, many political, social troubles that we have there. But again, our rock is built on some level of cooperation from the Egyptians, from the Israelis, and that's very fragile.
Chris, there's a laser pointer on there if you want to use it.
Oh, okay.
It's a green button, I think.
We have this thing that says you got to be smarter than your equipment. Okay, here. Now that we got the political context, here's what really matters. That's the watershed of the Nile River. Now let me translate for you. Over here, we have the rainfall in inches per year. On the left-hand side is the rainfall. 40 to 80 inches a year land in Rwanda and in the tropical regions of Middle Africa. Plentiful water, green stuff. Then 30, then 20, then 10, and then 0. You want a little irony? As the Nile River flows north, the Aswan Dam is right here as it enters Egypt. That was built for Egypt by the Russians in about the 50s. That's where Egypt measures the amount of water that comes over the dam and flows north into the cities and the populated areas and the agricultural areas. That's where they measure the lifeblood. Now here's the irony. There's also a weather station at Aswan. There's thousands of weather stations all over the world. Aswan is the overall fifth driest place in the world. So Egypt measures the amount of water they have to survive at the fifth driest place in the world. None of that water lands in Egypt. It is all generated by the upper riparian countries. Ethiopia, in here in the Democratic Republic of the Congo, South Sudan, not Sudan. South Sudan is the southern part. The amount of water at Aswan on an annual basis to the 100th of an inch is 0.00. That's as low as we record. It's silly to go otherwise. Over here, on this side, are the annual flows in billion cubic meters, as best we can estimate. It's a tough problem to really get it particularly accurately, but if you sum it up, it's somewhere around 140 billion cubic meters of water on an annual basis for that whole watershed. Now here's the conundrum, and this is where the population comes in. Now, here's the best use calculations that we've got. There's 12 countries in the watershed, but I only used the ones that use a significant amount of water out of the watershed. And if you total that all up in the current water demand, the demand is just about equal to the supply. Right now, this data was done in 2011 population. That 140 billion serves 265 million people that now live in that watershed in those countries that use it. Now let's pan forth to 2050. In 2050, those population statistics, and it is linear to 2050, there'll be nearly 700 million people. They didn't follow your rule, ma'am. They have population growth rates there of doubling every 30 years. 700, going from 265 million to nearly 700 million, nearly 3 times the population. If you just linearly extrapolate, this says they need 230 billion cubic meters of water on an annual basis. And that river cannot come anywhere close to that level of production. So by 2050, water is a critical element. Now, when I was here before, I talked to folks because I've had 2 international students. We have about 120 international students a year in my college at Fort Leavenworth. The brightest people you've ever met in your life. They only send their very best over here. And the one from South Sudan and one from Egypt both did their master's thesis on water security issues in the Nile River. The South Sudanese thesis question was, will our ability to use the waters of the Nile cause our country to fail? It is a critical component of whether South Sudan survives. They just became a country in 2011. This young man wore People's Liberation Army on his collar when he was studying with me. He had been a child warrior since he was 12 years old. He had been fighting the Sudanese government until this country became a country in 2011. He was about a 40-year-old man by that time. An amazing guy. He said in his thesis conclusions, we all need to work together in the Nile River Basin to develop the best uses of this water for the benefit of all. Cool. I mean, a guy had been a child warrior, had been in combat just constantly. That was his view of the world. It was just amazing to work with a young man like that. The Egyptians basically said Egypt will do whatever it has to do for their rights to all the water of the Nile that they want. And I showed that to another Egyptian student to confirm that in a lecture I did in my college. And he says, that's not exactly right. Egypt sworn to go to war over whatever they need for the water. And if you've looked at the news in the last year and a half, there's been some saber rattling between Egypt and Ethiopia about dams that are being built by the Ethiopians. But we may find a political solution there. There may be a way to balance out the needs of both there. That's what we hope for. So I would put in a positive note. Some people note that some of these issues may be the reasons to start talking and cooperating together rather than go to war. And that's what we hope for. Because it's going to take some significant cooperation to solve this. This is not unique. This is just one of my favorites. But you can look at many rivers. You want scary, the Tigris and Euphrates rivers. All of that water comes out of Turkey. Turkey's building dams all over the place to use it for energy, to divert it to their arid lands to grow more food for their population, increase their economy. If they do everything that they want to do, the Tigris and Euphrates at Baghdad will be 95% dry. Like they don't have enough to fight over there. You know, water is the issue of the Middle East. There was a question, somebody had a...
I had a question about land grabbing and the whole idea that some of these areas in Ethiopia are being bought to be used for industrialized agriculture, which is very water intensive. And I'm wondering how that would play in. I mean, it's not always for food good for that country's population.
It's always multiple use. When you're trying to get water, it's about growing food, it's about producing energy, it's multiple uses that you design the system for. They don't always have to be bad, but if they're going to use massive amounts of it, because agricultural is use and a loss. Some of them are renewable kinds of uses. I don't know about there, but I was in Nigeria last year, and the Chinese are buying up massive tracts of arable lands in China to put in major food producing areas because they cannot grow it. They have big water problems, as you'll see. Please, sir.
I Googled world drought map.
Yeah.
And the Middle East is all in a drought. And that's where all this conflict is. I mean, it makes sense that you're going to have conflict where you have droughts.
Yeah, but it's worse than that because there are many places where the population growth rates are so high that even though they have water, they can't produce it and deliver it to the populations. As we urbanize, more than 50% of the people of the world now live in cities. We've just gone past that tipping point. Many of those cities can't provide adequate water because the populations are growing so fast. I was in Beijing 6 months ago. They have a plan to turn Beijing into a city of 100 million people. 2 weeks after I left, they had to shut down the buses and the factories because they couldn't breathe the air. And it was real. I mean, I've been in Kabul. I've been in every nasty place I think you can be in the world. I've never seen anything as the air pollution in China. And that's just kind of a symptom of the overall, when we start compressing ourselves into those spaces. You have to feed them, you have to provide water. That has to be imported somewhere. And most of the world can't afford to do that. China can afford it, but most of the world can't afford to do that kind of stuff. So if you look at Brazil, you look at Sao Paulo and Rio in Brazil, they got the nice area. They want you to go out back. That's where millions of people live on the hillsides in tin shacks, and they walk to get their water. The sewage just goes where it goes. It goes downhill. That's the basic rule that we apply when we design sewer system. It ought to go downhill.
On the question about the Colorado River and Denver and Colorado and Arizona and California, is that how, on your level of seriousness, how serious is that now?
It's pretty serious for the folks in California because the water that they're taking out, it's a portion. It's supposed to be a portion. We have water rights and stuff, but everybody cheats. And if it continues to dry up, has anybody seen pictures of Hoover Dam right now? I mean, their lakefront property is not lakefront anymore. It's about a high dive to the water from many of those places. It's still drying up, and it's still drying up. That's the water supply that Las Vegas, many of those arid lands have. I mean, it's almost ludicrous when you think about trying to farm places like the Imperial Valley in California. That's a desert, but it's a huge, huge place to grow crops because all the water is irrigated. I mean, water comes in from the Colorado and other places. They take it from Northern California. It is a complex system that continues to cause significant problems out there. You know, they've got major water shutdowns, but they still have golf courses, and you still see water running down the streets in Phoenix, where they've got to water every little piece of grass. Please.
The writer H.G. Wells once said that history is a race between education and catastrophe. And it seems
Who's winning?
Well, it seems like we're well up to our eyebrows in catastrophe or imminent. And I love hearing more of the details and the specifics. But it seems that we're now at 400 parts per million with CO2 in the air. I think of the organization 350.org some time back that they thought that would be the top, and now we're at 400. Well, we're at the other end of trying to get out of this hole. I have a geologist person friend I admire, and she said she never thought she'd ever say, we now probably need to start sequestering the CO2 because we're at a point, and all the spin-offs of the things you're talking about all over the world, it seems like the information to even make a decision, no one knows any of this, relatively speaking. I have good, well-educated people with college educations. They know nothing of this. As a matter of fact, they don't even want to know anything of this. So it's really creepy, scary in this country, let alone other people around the world. They definitely know there's problems, but you know they wouldn't be able to articulate it. How can we get this message out when there's so many strong forces, gazillions of dollars, making sure it does not get out?
I'm more positive than I was 2 years ago that we're starting to turn the corner there. I've become better educated on that, and I'll talk about that as we go along. But you got the point right. Yeah, we don't know everything, but we certainly know enough to act very, very strongly and responsibly right now. Now, we're going to go into the climate change, the data. That slide has nothing to do with the climate change. I just have this mortal fear of snakes, and I found out. I just use it whenever I can. Or you can consider yourself, you're at the other end, and climate change solutions are at this end, but you have to come through. However you want to look at it. Is that the future of climate change? I'm not ignoring you. We're going to get to that, though, because we're going to talk about the data. Now, I'm going to very quickly, not everybody has studied the science, so I'm going to go back and just really briefly go over the fundamentals of why climate change is occurring. I think this place, I don't have to apologize for this. God built a beautiful system. In fact, He built a system of systems that works perfectly for our sustainment. We know the sun provides us all the energy. It does that in very short wavelength energy that comes in, penetrates the atmosphere, and hits the earth, both the water and the land. A component of that is reflected back off as longer wavelength energy we call heat. If that all went back into the atmosphere, we would be about a minus 173 at certain times, and then we would be hotter than the place we don't want to go to at other times. But because we have these things called greenhouse gases, these guys, in the atmosphere, in very small concentrations normally, and 400 parts per million, that's 400 pieces out of a million pieces. That's a small number. That's why the deniers like, that can't make a difference. Really? But these things together have the ability to absorb that heat energy, warm the atmosphere, and then reflect it back to the ground. That's the blanket. That's the greenhouse is not exactly a right science, but it's close enough to describe this system that keeps the Earth at a moderate set of temperatures. So, going back to my statement before, when we have more of this in the atmosphere, the greenhouse gases, it tends to capture more of the heat and not let it go back into space, which causes the atmosphere to warm, the land to warm, and again, 90% of this heat ends up going into the ocean, warming the ocean waters. If this system, you continue to add CO2, the temperature continues to rise, or the other greenhouse gases. It's a thermodynamic process. Pretty well known. The complexity is, how does the ocean water interact with the carbon dioxide, the land mass, and the tropical forest? Where does all the carbon go? Getting an exact carbon balance is still some work to be done. But we got 90% plus of it accounted for. And it doesn't bode well unless we quit putting massive amounts of this into the atmosphere. Questions about that?
So right now, the ocean is taking in a lot of the carbon dioxide too.
It always has, but it takes in a little more.
Yeah, eventually you're gonna reach a point that it's not gonna be able to speak.
Well, we have changes that are going on. One, it's warming. The other is it's getting to be more acidic.
Right.
So that changes the whole food system, because as it gets more acidic, it kills off a certain kinds of plants and let other kinds of plants grow, and the whole food cycle gets mucked up. More than half the people in the world live right next to the ocean. Many of them depend on the food as their primary supply from the ocean. So that's the issue. Good? Does that?
Yeah.
Okay, good. So we got that.
Oh, I've
Water
got a question.
vapor?
Please, ma'am.
So
I'm
does
sorry.
any of that, do any of those changes to the ocean affect the ocean's ability to absorb carbon dioxide, or?
Well, if you have more in the atmosphere, it tends to try to take in a little bit more. So as the higher it gets, the more acidic it's going to get, and the more it soaks. But it's not keeping up. It can't soak it all in. That's why we're still seeing increases in carbon dioxide rates, as described, over 400 parts per million now, and still climbing.
Water vapor you had on your list?
Water vapor is one of the
And warmer air can hold more moisture?
more heat. More heat. It's able to capture more heat. It's just a very, very specific chemical property as to which absorbs long wavelength. Nitrogen doesn't absorb long wavelength. It would go back out in the atmosphere if it was just nitrogen in the air. So each one has a different absorptive capacity. The biggies are carbon dioxide. They can absorb lots more. Methane or hydrocarbons absorb lots comparatively. They're very strong. Nitrous oxide, not very much of it, but it absorbs too, and ozone absorbs. So it's a combination of all those. And most of those things are lately industrial property chemicals, not the natural system. So, you can study here and you start seeing, well, what's the impact of that accelerated climate system? It changes the whole hydrosphere. How much water comes when, where it goes as far as runoff or going into the groundwater. The groundwater is where most of the people in the world get their drinking water. When it starts influencing that, it greatly influences people's ability to survive. For example, the reason they're having problems in Kansas, in West, is because the aquifer has been pulled down so low they can't get the water out anymore, or they can't do it economically. It's just too expensive to lift it hundreds of feet. Where it used to be just right at the 30, 40 feet below the surface. Some of that is climate change. Most of that is overuse. It's just man's use for it. Growing more and more foods, crops that you wouldn't normally grow here, but if you have water, you can produce food at high levels. We'll go over some more of this. So, just the facts. I have it broken down into two sections now. These are the data from the IPCC's 5th report, which was issued in 2014. These are the actual measured changes. It's not models, it's not guessing. These are the measured facts. Since we've been recording data, here's what we can say we know about it. Now, the wonderful thing about the IPCC report, it's thousands of scientists from all 195 nations. Anybody that believes this is some sort of clandestine operation to trick the whole world doesn't understand what happens when you put 195 scientists from all over the world into one room. They will not agree on anything. So when they are willing to sit down and publish this data, it has been scrutinized and scrutinized. And they will not report anything unless it's highly, highly, highly likely, the lowest possible error in the data before they'll report it. And if they don't have data, they won't report it. And I'll show you that example in a minute. The Earth has warmed up 8.85 degrees centigrade, 1880 to 2012. That's on average across the world. There are many places where it's warmed 2 or 3 degrees centigrade. In the middle of the large land masses like Siberia, in the middle of the United States, it is significantly warmer because that's the way climate works. The lands heat and cool more than the water. The water just absorbs the heat and warms it slowly. 90% has gone into the heat. The ocean is warmed 0.4 of a degree over that period of time. That doesn't sound like a lot, but the big significance there is what happens when you warm water as far as its volume to weight. It gets lighter per specific gravity, so it occupies more space. So the more water you warm, the more sea level rise you get. Sea level rise is the fresh water that is not being stored on the land, plus the ocean as it grows because of the warming effect. This is the one that's most immediately scary to me. The changes in the cryosphere. The amount of water that's stored in ice and snow. That's another one of God's perfect systems. I'm a Corps engineers guy. We love messing with water. We can't design anything that pretty. It collects it up in the wintertime, releases it across the whole rest of the region. You don't get as much flooding in the spring because some of the water is stored. Of course, if it releases it too fast, then you get flooding. And then you have water in the summer because it's still releasing from the high mountains. I'm going to use the Tibetan Plateau to show the example of that. The rate of loss in ice, of the Greenland ice cap, and we know what's happening in the Arctic and Antarctic, losses of 3.5 to 4.1% per decade. Folks, in geologic time, that's like setting land speed records for change. That's huge in the amount of storage capacity that's being lost. loss of permafrost. That's another one that's kind of scary, because all of the frozen north is a huge sink for methane. Anaerobic gases are the product of decomposition, not with oxygen, but without oxygen. So all of it's swamp gas. If you know something about southern Florida, we call it swamp gas down south. It's naturally produced, it's methane, but a lot of that methane is stored in the frozen north. And if it's released in large quantities rather rapidly, then the amount of greenhouse gases suddenly go out uncontrollably. Because remember, as I pointed out, methane is one of the more virulent, more reactive greenhouse gases. That's why the cryosphere is so worrisome to me. Here's the data on sea level rise. The best we can tell, carbon dioxide, methane, and oxides of nitrogen haven't been this high on the planet Earth for 800,000 years. Now that's the best science that's available. It's dealing with ice core samples that are millions of years old and those kinds of things. But it's a reasonable amount of knowledge that data reflects what was going on over the Earth. And at least half of it, we're absolutely sure, extremely likely, was generated by the anthropogenic changes in the atmosphere. The natural system is still going along. It still warms and cools over hundreds and thousands of year cycles. This is added to it. And it's overwhelming the natural system. One of the great things that I've seen is congressmen are interviewing the president's climate change guy. So, and it's the House Committee on Science and Technology that's doing this. So these are the smart guys. So the one congressman in Texas, he's got the guy. He's got this PhD dude that the president set up there. So, tell me, Dr. So-and-so, does your model account for global wobbling? That's a real term. That's a real term. You know, the Earth doesn't spin perfectly. It changes shape and it spins a little bit off cycle. And that does change the impact of how the Earth impacts with the sun's rays. And so it changes that a little bit. And the president's man said, no, we don't put global wobbling into our climate model. Ah! I got you. And he goes on and on for about 10 minutes. So tell me then, why you didn't put global wobbling into your model? Because obviously it's no good. Now, the sidelight is, this is being shown by John Stewart. He's doing some interpretive discussion in between this. And I can't show it because it's pretty vulgar. But it's pretty accurate, too. So the president's climate change guy looks at the congressman and says, without breaking a grin or anything, says, I so enjoy my engagements with you, Congressman. And then he says, global wobbling occurs in timescales of 22,000, 44,000, and 104,000 years. So to estimate the climate for the next 100 years, we did not account for global warming. And there was some other stuff in there, but Stewart ended by saying, how far back in grade school science do we have to go to reach the level of understanding of the U.S. Congress? And it wasn't the U.S. Congress, it was 3 guys. And then he pulled out the data and showed who had participated in their campaigns for the last 3 terms. And number 1 was one energy company I didn't recognize. Number 2 was Koch Industries. And number 3 was another major coal and gas producer. That's what we got to start dealing with, is getting the right people representing, I think, fairly the information that's available. These are just the facts. So here's some of the maps that came out of it. And understand, this is the map of precipitation. There are winners and losers in this, as you'll see when we look at the U.S. data. Some places get more habitable. We'll have a little more warmth. We'll have a little more water. Maybe we'll be able to produce food at higher rates. The problem is most of the people are living in other places than that and have been for the last 100,000 years, because those were the best places to live, this belt here. Temperatures, there's the global scale of what temperatures have done over the last 110 years. Now, what is the white stuff? That is white because there are not points to measure there. And the IPC will absolutely not report anything that they don't have an absolute value of. Other scientists, what we would do, we would just do averages across the pixels and draw that in. They would not do that because it was not defensible. That just adds to the validity of the work that's going on in my view. And you see there's one place in the world that's cooler because of the strange cycle of both the climate and then the ocean cycle.
What about southeastern US where it was lower?
There's a couple of places right now that it has dropped because of that. Just the natural cycle of things. This is where we are. This is warming significantly. This is what has already occurred. And what you see is, as I pointed out, the recorded changes over this period of time. In some places in the world, it's gone up 2.5 degrees centigrade already. The drops are in tenths of degrees centigrade. So it's not fair to say, blue doesn't equal dark red. It's a minor change to a massive change. Okay. We want to get several things off of this. The first thing you want to see is each of these boxes that I have put on here represent major drivers caused by climate change. Climate change causes extreme weather, changes in both the amounts and the timing of precipitation, sea level rise, floods and droughts. And here's the bad news. In the same place sometimes. Snow and ice cover change. Excessive drying of the land. Those are the major impacts that particularly have security implications that are the results of climate change. Remember I talked about Bangladesh. Here it is. It sits between India, China, the rest of Southeast Asia. This area represents 3.2 billion people. Half the world's population lives off the Tibetan watershed. Now, from a security standpoint, the first thing I pick out on the map, 3 of the largest armies in the world and 3 nuclear powers. That's what you have to look at. What's the risk? The risk is pretty heavy if you've got 3 guys with armies that are over 1 million people plus, and they all have nuclear weapons. That's a concern to me. The previous 4-star general that oversaw all of that region said climate change is his scariest thing. The new one has changed his mind and said it's not climate change for him, it's access to this. But climate change is still high on the list. So what happens? This normally has massive amount of snow and ice that it collects up. It slowly releases it over the summer periods, and it feeds the 7 major rivers of the world. The amount of ice and snow cover in the Tibetan Plateau is dropping dramatically. If this continues over time, what you will see is massive amounts of flooding in the springtime, and things like the Mekong River are predicted to go dry in the summertime. It's everybody wins or everybody loses in this one. That's where we got to get the message across. It is everybody. And the developed nations have to see it's in their critical national interest. We can't say, okay, I don't care that 35 million Bangladeshis are going to have to move because sea level rise is going to take over all of this land and flood it. Or, when they have extreme weather, this is Typhoon Alley back in here. Just like this is Florida, this is Typhoon Alley, the way the hurricanes come across on us. Millions of people here die. because they sit right in the margins. Their feet barely dry. When the water comes up at all, either from sea level rise or from spring floods, a lot of people die. They die immediately from flooding, and then they die because of disease that follows disaster. It's biblical. The one thing that we want to say about the fifth assessment report, the data just reaffirmed things we knew from the fourth and the third, except in one circumstance. And it gets to what the young man was talking about. We had grossly underestimated the rate of loss in sea ice and ice and snow cover. We didn't think the Arctic was going to be open waters this early. The predictions now are no sea ice in September 2050. It will completely go away, and then it'll reestablish itself in the wintertime. But it won't reestablish itself in a way that it's the same ecology that we had before. And the reason is what he was pointing out. As the snow goes away, say there's snow here, 95% of the sunlight that hits that reflects back into the atmosphere. But when it's land, 90% of it absorbs. When it's water with ice on it, 95% reflects back. As soon as the ice goes away, it starts absorbing all of that, and the water gets warmer, and it doesn't freeze as soon, and you've got a vicious cycle, and we underestimated that cycle. The other thing that we got from AR4 to AR5, the two reports, is much more certain. We had listed a whole lot of things as most likely, but not, weren't absolute about it. We have much higher certainty on the predictions that we have now than we had before, because the science has improved. So here's how I look at it when I look at one. This is the climate driver, one of those guys from this map. For this one, the key impact, the key concern in the Tibetan Plateau is the ice and snow cover and what impact it has on the hydrosphere. Ice 15 to 85% gone by 2100. Snow cover 7 to 25% lost by that. That's massively destroying the water resource system there. It stresses water recourse, increases the rates of warming, increases flooding and droughts throughout the region. So from a military standpoint, the immediate issues I have to recognize is I probably have lots more humanitarian support operations to do in that region of the world. Large-scale logistics support. Medical resources respond to epidemics. Again, epidemics follow a disaster. Border security issues, and maybe the source of conflict between neighboring states as these mass migrations and refugees are created. I'll give you an example again. In Rwanda, we were there for about 120 days, supporting 1 million people in a refugee camp. This was in '94. We'd just come back from Saudi Arabia and the Desert Shield Desert Storm in '91. We could hardly sustain that mission with all of our airlift capacity because our planes were kind of worn out and stuff for 1 million people for 120 days. I was the medical ops planner for the thing, trying to plan getting the medical logistics down there and then sustaining us. We had a force of 700 or 800 military down there. We didn't treat one Rwandan. We depended on Doctors Without Borders and all of those wonderful, wonderful people that just show up in the disaster. But it nearly wore us out. The scary part now to me is when I look at that is both the scale of the problem, how many people might be refugees from this, and the second is how long it lasts. We barely hung on for 120 days. What if it goes on for 10 years, like the drought in southern Sudan, or those other issues? You know what? We just don't go there. And it gets worse and worse.